Question 6 is asking you for the electronic configuration of sulfur. Well, you look at the periodic table to look at the number of electrons in sulfur, and it has an atomic number of 16. So therefore you know that it's got 16 electrons. 1s2, 2s2 is 4, 2p6 is 10, 3s2 is 12, so therefore you've got 3p4 left over. And the next question is asking you to draw the dot cross diagram of sodium sulfide. So first thing, you need to recognise that the formula of sodium sulfide is Na2S. Second thing, you need to know that the sulfur has gained 2 electrons to form its 2- ion. So that was your first mark. Second mark was to show that each sodium had a positive charge. Each sodium had an empty shell, and there were 2 sodiums. And you had to show the sodiums at opposite ends, because obviously 2 positive things next to each other repel. So they had to be at opposite sides of the sulfur to avoid that repulsion. In the part B question, you've got which statement is true about sodium sulfide. Well, you know that sodium sulfide is ionic, and therefore you've got a lattice 3-dimensional structure, which is very, very hard to break down at room temperature and pressure, so will not conduct electricity at room temperature and pressure because the ions are static, whereas when you heat it up, the ions become mobile and can therefore carry charge. So it will conduct electricity in liquid state but not in solid state. So the answer is C. It would also incidentally conduct electricity in solution. The next question is asking you about the relative melting points of sodium sulfide and sodium chloride. And it's saying that sodium sulfide is higher. And the question is why? Well, you're comparing a sulfide ion with a chloride ion and a sodium ion with a sodium ion. Sulfide is 2-, chloride is 1-. Sodium and sodium, there's no difference. It's not due to the fact that there's a sodium ion present. Sulfide has got a 2- charge. Therefore, that positive charge is going to be more attracted to that 2- charge. So therefore, the bond is going to be stronger. Remember, an ionic bond is actually just an electrostatic attraction between something that's positive